Learning. There are two different trees in the system. The neighbor tree organizes all the organs based on the spatial neighboring relationship between organs. The system will list its neighboring organs in the next layer. The type tree organizes all the organs based on the organ types. The system will list all the organs in the same type, such as muscle, in the next layer, based on the organ types. Both trees has a display and an examination mode. In the display mode, the organ can be selected as the center organ. The system will display its neighboring organs in the next layer. By clicking on the name of each organ, the organ can be displayed along with its spatial relationships with others. In the examination mode, the organ will be displayed alone first and rotated automatically so that you can examine its shape clearly. You can change your viewing direction by yourself. You can click at the icons to control the visibility of each organ. One click will make the organ become semi-transparent. One more click will make it disappear. One more click will make it appear again. This icon here will help you to understand your perspective on the organs. By clicking on explosion and adjusting the scroll bar, all organs can be explored and the spatial relationships among organs can be visualized. If you press the annotation button, the annotation buttons of the organs will be shown. The annotations will disappear when you release the button. Gaming. The gaming section has two modes. In the display mode, you should select one neighboring organ of the center organ at a time in the organ list. If it is correct one, it will be displayed at its location in the 3D image. When having difficulties in continuing the game, the help button can be clicked as the next step to show the answer. In the examination mode, you do the same thing as in the display mode. If the selected organ is correct, you have to pick one point on the center organ and the selected organ will be displayed around that point. You can use the mouse to fine-tune the location of the organ to the correct location. In other words, you are using all basic building blocks, the organs, to reconstruct the knee as a game. All activities will be recorded and shown at the end of the game to indicate your strengths and weaknesses. (2D, 3D image integration). In the 3D image, when the 3D to 2D is selected, the corresponding 2D cross-sectional image will be shown. You can visualize what the point will look like in a 2D image. All kinds of associated 2D images can be selected in the right-click pop-up menu. all the 2D images can be shown in different ways to help users to understand how to interpret 2D images. In this window, all the 2D images going through that particular point will be shown. When you click at a point, all the corresponding points in various 2D images going through that point will be shown so that you can learn what the same point in different images looks like. If just a series of 2D cross-sectional images is used for the learning, it is difficult, particularly for a novice, to imagine where each 2D image is located in the human body. In any 2D image, you can also click an organ and select the 2D to 3D item. The system will show the selected 3D organ and the 2D image together in 3D space so that it is easier to know where the 2D image is with respect to the 3D organ you selected in the 2D image. You can also move the 2D plane around to visualize the 2D images at different 3D locations. Test and a surgical simulation. In the first question, this is the targeted organ. Every organ has a number as its annotation, and you should enter a number for the targeted organ. To answer the question, you can set any organ to be invisible if you think it obscures the targeted organ. In the second question, the 3D image simulates what you see in an operation room, where the organs can be seen only through an incision. In this question, the incision was set by the instructor beforehand. You can set each organ to be invisible to simulate push aside the organ to reveal organs underneath in a real operation until the targeted organ is revealed. IIS for learning anatomy. In reality, the instructor and the students can use their mobile phone to log in the IIS website. For the demonstration of IIS, you can click the button to automatically log in the IIS system as an instructor and 2 students respectively. You will see 3 browsers showing what the instructor and the students will see respectively. As an instructor, you can activate each question. You can set the time duration for students to answer the question. Then the students can see the question and answer the question within the time duration. The statistics of the students' answers can be shown when the time is up. Both students and the instructor will know how well the students are learning.